Well, how's everybody doing out there? Well, welcome to day 18 of Corona Online School. So, today we're going to start chapter 6, which we'll spend a little time in. And so, we're actually moving into the fraction section. So, this is usually everybody's favorite part. So, I hear a bunch of groaning going on in the background there. So, let's no groaning. We're going to love fractions. We're going to do good in this section. And by the time it's all over, we're going to know fractions better than we ever have before, hopefully. So the first thing I want you to do is before we even start talking about fractions is kind of work on practice 1, 2, and 3 real quick. So without formally talking about fractions or anything. So at this point, just stop the video or pause the video, work on these first 3, see how you do with just your, whatever you remember about fractions at the moment. And then we'll come back in and go through the formal definitions of fractions and stuff like that. So again, at this point, pause the video, see how you can do on the first couple practice problems. If you get stuck or have any questions on them or anything like that, just let me know. And then when you're done, come on back and then we'll move into the rest of the packet. All right, so hopefully everybody did a good job on those graphs or those pictures and stuff, trying to divide the rectangles up and stuff. So at this point, we're going to go through a bunch of definitions that we're going to use related to fractions. So I'm going to pull the PowerPoint up. So if you want to write them down as we're going through the PowerPoint, or if you want to pull the PowerPoint up and write them down separate, you can do it however you want. So the first thing we're going to talk about is a whole or a unit amount. And so let me pull up the PowerPoint here real quick. So a whole or a unit amount is an object, a collection, a set, or a quantity of things. So it could be anything. It could be a group of people. It could be a pizza. It could be like a glass of water. So you name it. So in this case, I've kind of drawn some of the things that we're going to use to model fractions with. So we'll talk about these definitions later. But we've got a nice little six-sided shape. So we've got a hexagon, we've got a circle, and at the end, the thing that looks like a big domino is going to be what I use to represent our set model in this case. And so in this case, since it's the whole, notice everything's all filled in for each of these guys. So in this case, this would be like same thing as, whoops. Oh, hold on, my son used the pen. I forgot to sync it. Give me a second here. Hopefully it'll pair up here quick. There we go. So the first one, since it's a hexagon, what you would do is you would count the whole, the number there. So we've got 1, 2, 3, 4, 5, 6 sections. So this is technically the same thing as 1, but from a fraction perspective, we can think of that as 6 over 6. So just kind of think of it that way. So same thing with our circle. So our circle is divided up into 4 regions. So that means this is still 1 because all the regions are colored in. And so we think of this as 4 over 4. And so in this case, all my dots are filled in black. So that means they're all colored in. So again, this is going to represent 1, but I've got 12 blocks or 12 circles in there total. So this would be the same thing as 12 over 12 for our whole or unit amount. All right. So let's move on to the next one here. So our next one is what's called the unit fraction. And so it's always written as 1 over b. So in this case, so it's just one section of our big object that we're talking about. So in this case, it's the quantity formed by one part when a whole is partitioned into b equal parts. So same thing. So notice in all the different colors now I only have one thing shaded in for each one. So in this case, my B for the first one is 6 because we've divided our hexagon into 6 little triangles. And so our fraction for this would look like 1 over 6 in this case. So same thing, our circle still divided up into 4 sectors. So in this case, our B would equal 4. So as a fraction, this would look like 1 over 4 as our unit fraction. And so now notice in the last one, I only have one that's actually colored in. So all these ones that are open circles are just letting you know what the total number is, but the only one that's actually colored in is that 1. So again, in this case, our B would be 12 since we have 12 circles in there total. But since only one of them's colored in, as a unit fraction, this would look like 1 over 12 in this case. All right. Is that okay with everybody? All right, perfect. So let's move on to just regular old fraction. So regular old fraction is the quantity formed by a parts, so that's going to be our top number, of size 1 over b. So in this case, we're thinking of like our, so we're still thinking of this as a unit fraction, but then we're just adding however many parts to that unit fraction that we can actually get. So in this case, I kind of wrote the answers down for you. So in this case, we had 2 blue that was shaded. So we've got 2 parts of size 1 over 6 in this case. So that's where the 2 over 6 comes from. And then the circle, we've got 3 shaded red. So that means we've got 3 parts of size 1 over 4 in this case. And then finally the last one. So now we've got 5 black dots colored in. So we've got 5 parts of size 1 over 12 in this case. And so that gives us our fraction. And so again, I went through and kind of described, in case you forget, the top number is what's called the numerator. The bottom number is called the denominator. And so again, the top number is just the number of parts. And the bottom is just that B number, that equally divided number of sizes that we have. All right. Is that okay with everybody? Good. All right. So for the next one, we're talking about what's called a proper fraction. So a proper fraction is a fraction where the numerator is always smaller than the denominator. And so in this case, I'm using a different model. And so I'm going to talk about the models here in a little bit, but this is what's called a fraction strip. So I'm kind of using all the different models here just to give you an idea of all the things we're going to work on. And so in this case, since we've got 4 things shaded in out of 5 parts total, so we've got 4 parts is going to be our top number, of a size 1 over 5 is going to be our bottom number. And so in this case, I don't really know what color this is, so I called it purpley maroony color because it's kind of some oddball color that I was able to produce on the computer. So I don't know what the official name for it is. If anybody knows the official name and wants to let me know, they'll get bonus points. So, but for me, it's going to be purpley maroony. All right. So the next one's an improper fraction. And so this is kind of the opposite. So this is where our numerator is going to be larger than the denominator. And so notice in this case, instead of having just one row or one fraction strip, in this case, I've actually got multiple fraction strips. So in this first case, I've got 1, 2, 3, 4, 5. So notice I've got one whole from that first one. And then I've got one. And if I keep counting, well, I'll get to that in a second. Don't worry about that. So I'll keep counting. So let's see. So this will be 6, 7, 8, 9, 10, then 11, 12, 13. So I've got 13 parts that are actually colored in out of, in this case, so even though there's 15 blocks total, remember our size is based off of just the one strip in this case. So our one strip is broken into 1/5 increments. So that's why it's 13 over 5 instead of like 13 over 15 or something like that. So because these are individual strips in this case. And so again, this is that same fancy purpley maroony color that I had before. All right, everybody okay with improper fraction? All right, good. So then we can do a mixed number, which is kind of what it sounds like. So a mixed number combines 2 different numbers together. So it combines a fraction with a whole number. So the main thing to remember about a mixed number, since it has a whole number in there, these are always going to be things that are bigger than 1. So it's always going to be that way. So now I want to do what I was trying to do on the last problem when I shouldn't have talked about it. So in this case, so it's the same shading. So I had 13 blocks that are shaded in, but now I want to think of them in terms of how many whole number blocks do I have and how many fraction blocks do I have. So in this case, this first block is completely shaded in. So that means that's going to be one whole, or again, like I talked about on the first page, like 5 over 5. The second one is completely shaded in as well. So that's going to be a second whole in this case. And then I've got 1, 2, 3 partials that are shaded in. And so again, This is broken up into 1/5 units, so my denominator is still going to stay 5. So in this case, I would end up with the 2 3/5, again, of my purpley maroony color here. All right, so is that okay? Everybody okay with the mixed number? And I think that's it. Yeah, so that's all the definitions that we need for right now. So if I went too fast, feel free to go back and look at the slide. I'm going to post a slide up with the notes and stuff like that. So if you want to write these down before we even look, I mean, that's totally fine. So let's go back and keep working on the packet sum. All right, so that should have filled out all the definitions for us there. So now what we want to do is look at all the different fraction models that we're going to cover in this section. So in this case, our fraction models are going to fall into the categories of colored regions, which are basically just colored polygons is what we're going to use. Fraction strips, which I showed you. Fraction circles, which was on there also. And then set model, which we saw a picture of. So the only one we didn't see was the number lines. And so, but we're probably familiar with number lines anyway. So the very first question or example here shows us a couple different set model colored regions that we had and wants us to identify the fraction represented by the colored regions. So for me, what I like to do first is I always like to figure out how this thing's divided up. So I want to usually figure out what the denominator is first and then go back and figure out how many parts I actually have shaded in. So in this case, if I go through and count, so this is a nice hexagon, so it's got broken up into 6 equal triangles. So our bottom number in this case is going to be 6. And then how many colored regions do we have? We've got 1, 2, 3. So I've got 3 parts of size 1/6 in this case. So again, kind of keep that in mind. So 3 parts of size 1/6. All right. And so for right now, I'm going to leave it that way. Like we'll talk a little bit about simplifying, but for right now, don't really worry about simplifying fractions. That's something we're going to do later. So for right now, just write it down the way it is and pretend like you don't even know how to simplify at the moment. But all right. So the next shape we've got is a pentagon. So again, first thing I would do is count how many different regions I have. So in this case, I've got 5 regions. And so how many are shaded in? So just 1. So in this case, I'd end up with the fraction 1/5, or again, 1 part of size 1/5. All right. So lastly, I've got an octagon, it looks like in this case, so 8-sided figure. So again, let's count the region. So it has 8 sides, so that means, or 8, well, it has 8 sides too, but it has 8 regions on the inside. And then how many of them are shaded? So 1, 2, 3, 4. So I've got 4 that are shaded. So again, in words, this would look like 4 parts, not ports, of size 1/8 in this case. All right, so I left the next couple for you guys to actually work on. So in this one, we've given you the colored regions, and you have to shade them in. And then we've got one with fraction strips, where we're going to identify what the fraction is based on what's shaded in. Then we're going to do the same thing with fraction circles, shade in the required region. And then we've got set model, where we're going to circle. So in this case, I'm just going to have you circle the objects that are in there for, so circle 7 out of 12, 8 out of 21, 5 out of 9. And then number line, just a matter of plotting the proper point on the number line and then labeling them ABC so we know which ones go with which number and stuff like that. So pause the video at this point, go work on these practice problems, and then when you're done, come on back and we're going to look at how to apply some of these definitions to a bunch of different practice problems. All right. Well, hopefully everybody did a good job filling those out. If you did run into any trouble or anything like that, definitely shoot me a message tomorrow so that way I can help you. Otherwise, what we want to do is we're going to look at kind of all the definitions, break down fractions into all kinds of different pieces. We want to think about them in terms of their, like the different models, number line, all kinds of stuff. So we're going to do a lot of stuff, kind of apply these definitions that we've been working on to all these. So I'm going to do the first one for you, and then there's 4 more for you guys to work on your own, just to make sure you understand the definitions and what everything's called and stuff like that. So in this case, first thing it wants us to do is write the fraction in words. So in this case, since it's 1/6, this would be written as 1/6 in this case. So that's what the fraction looks like in words. So next, it wants us to model the fraction as a set in this case. So what we need is we need to have, since our bottom number is 6, then that means we need to have 6 circles inside. So let me do that first. And so the way I'm going to represent them, if they're an open circle, then that means they just are a placeholder. And if they're colored in, then that means that that's how many parts we actually have. So in this case, I'm just going to start off with 6 open circles, just to represent that this set contains 6, is broken up into 6 pieces, basically, this little set that we've got. And since this is a 1 on top, then that means we only want one of them shaded in. So, and it doesn't matter which one, you can pick any of them. So in this case, that would represent 1/6. So it's divided up into 6 circles, and one of them is shaded in. So that would be what the set model for 1/6 actually looks like. All right. So for C, it says model the fraction as a part of a whole object. So you can do this however you want. If you want to use a circle, if you want to use a fraction strip, if you want to use a hexagon, octagon, whatever shape would be appropriate to kind of divide that guy up, it's up to you. So for me, just to make life easier, I'm just going to use a fraction strip. And so again, I'm kind of doing the same thing I did with the set model. I first want to draw my fraction strip and make sure I get it divided up into 1/6 chunks first. So that's going to be the first thing I do. So I'm going to take my fraction strip. And so now to divide this up into even 1/6 chunks, I need 5 lines. So let's get 1, 2, 3, 4, 5. And they're not too bad. They're close to the same size. So blur your eyes a little bit. Imagine they're actually all the same size. And so again, so that guarantees my bottom number is correct. So now for my top number, I need to shade one of these guys in. So since there's only one, I just want to shade one of them. And again, it doesn't matter which one you shade. You can shade any of them. So I'm just going to shade this weird random one in the middle in this case. And so that's what 1/6 would look like as a fraction strip. All right. So in this case, what's the denominator represent? So it's, again, like in general, the denominator is how we're going to divide up our piece. So it's how we divide up our set or object. So if we were looking at pizzas, it's how many slices we would make of pizzas. This is how we divide up our set or object. And so what's the numerator represent? So if the bottom, is how many slices of pizza we make, the top would be how many pieces are left over or how many pieces you ate or something like that. So it's the number of parts of the whole in this case. All right. So what kind of fraction is 1/6? So you might say it's a proper fraction, which is true because 1 is smaller than 6. But in this case, we want to use the best possible name for it. So in this case, it's a unit fraction, which is more because it has an actual 1 on top. So it is a proper fraction also, but the better name is unit fraction for this one. So this is a unit fraction. And so finally, now we're finally using the number line for the first time. And so what we want to do is plot 1/6 on a properly marked and labeled number line. So if you notice, I left it completely blank, so you have to do this all on your own. So for me, since I'm graphing something really, really small, like I'm going to use as much of the number line as possible. So don't do something like this and put like 0 and 1 there and then try to figure out how to jam 1/6 into this little teeny weeny spot. I mean, not that it's wrong, but if I gave you all this space, use all this space to try to maximize it. So for me, I'm going to take and put 1 way over there, because in this case I know my number is pretty small, so I might as well use the whole space that's available. So now what I need to do is, just like I did with this fraction strip above, I need to divide this number line up into 5 tick marks, so I can divide this up into 1/6 intervals. So again, try to do your best to make it so it's as even looking as possible. So in this case, let's see, so this will be 1/6, 2/6, 3/6, 4/6. Oh, well, that's good. I just messed it up. Hold on, let me start over. All right, see, we all make mistakes. So 1/6, 2/6, 3/6, 4/6, 5/6, and then technically this 1 would be 6/6. So now that I've got this divided up relatively even, I can tell they're not exact, but again, blur your eyes a little bit so you can see that they're close. So we want to plot 1/6, so we would just go and put a dot right on 1/6 in this case. All right, does that make sense to everybody? Is that okay? All right, so at this point, pause the video. And so I've got practice 9 for you guys to work on. Practice 10. So again, all these are kind of the same idea. You're doing the same thing, kind of thinking about what the definitions mean, applying them to these different numbers. So practice 11, and then finally practice 12. So again, if you get stuck on any of them, let me know, shoot me a message and stuff like that so I can kind of help you. And then when you're done, come on back and we're going to talk about how you can change an improper fraction into a mixed number, and then a mixed number back into an improper fraction. So take your time, work on those, and when you're done, come on back. All right. So in this case, this is a very important thing to learn how to do, because improper fractions and mixed numbers, even though they're actually equal to each other, it's sometimes better to have one rather than the other. So for example, and I mentioned this above in the little paragraph. So for me, when I'm graphing stuff, I don't necessarily want to use an improper fraction to graph things, because that might be a little harder to do. I'd much rather have it in the mixed number form where it was like 2 1/4, because then I know, okay, I need to go over 2 and then 1/4. If I had that same like equivalent mixed number, which is 9/4, I might struggle to try to figure out, well, where it would actually go graphing wise and stuff like that. And then on the other hand, like, I don't really like doing arithmetic with mixed numbers. So for me, anytime I have to do arithmetic of fractions, I pretty much change them into improper fractions right away, just because I like it better and I think it's a little bit easier. So this is going to be a nice skill to have, to be able to go from one type of number into the other. You may know how to do this, you may remember, so I'm just going to hopefully refresh your mind if you've forgotten how to do it. So in this case, we're trying to turn -17/5 into its equivalent mixed number. So the first thing I wanted to make notice on this, and the two I'm practicing are both negatives just on purpose, is the negative that you're using doesn't ever go into any of the calculations. So just kind of keep that in mind. So if you have a negative number, all that means is your answer is going to be negative. So the first thing I would probably do is say, okay, this is equal to some negative number. And now I'm just going to think of working with as 17/5. I'm not going to use the negative part anymore, because again, the negative is just going to tell me that the answer is negative. I've seen people that keep the negative in there, and then that usually messes their arithmetic up some. So just know, since it's a negative number, your answer is going to be negative, but then work with the positive version of this just to make life easier. All right, so to go from an improper fraction to a mixed number, what we want to do is actually divide this guy. Use long division. So what we're going to do is the 5 is going to go on the outside, the 17 is going to go on the inside, and then we just look and see how many times does 5 go into 17. So it looks like 3. So 15, 17 minus 5 is 2. So in this case, this is going to be our remainder. So the 3 is going to be our whole number. It's going to be the big number. The remainder is going to be our numerator. And our 5, the thing we use to divide, is still going to be our denominator. That never changes. So when we do these are always going to be the same. So the whole number is always going to be the top number. The numerator is always going to be the remainder, and the denominator is going to be what we divided in to begin with. So in this case, negative 17 over 5 would be the same thing as negative 3 and 2/5 in this case. And then I'm done. All right, is that okay with everybody? All right, hearing nothing, I assume that means everybody's good. So perfect. So let's do this reverse now. Let's go backwards for these guys. And so again, same thing applies. So even though this has a negative in there, all that tells me is my answer is going to be negative. But when I go over here and do my calculations, I want to actually use the positive version of this so I don't mess anything up in the process. So the way this works to try to go backwards is what we do is we actually take our denominator, multiply it by our whole number, and then take whatever we get from that answer and then add the numerator back in this case. So the way this is going to work is I'm going to do 8 times 5 is 40 plus our top number, which is 3. So 43 is now going to be our new numerator. And our denominator is still the same. So the good thing is, no matter how these problems work, when we're converting them, our denominator never changes. So our 8 was the original denominator, it's still the same denominator. And you can imagine that being true, because like if I thought of this as pizzas, for example, so in this case, 5 and 3/8, what that would look like in pizza form would mean I had 5 whole pizzas with no slices missing, and then 1 pizza that had only 3 slices left. So if I put these together, then the 43 actually just tells me I have 43 total slices of pizza out of 8 slices for each pizza. So again, that bottom never changes when we're talking about these conversions. So in this case, writing this as a mixed number, I get the 43 on top, 8 on the bottom. And again, I just carried the negative over. So again, don't include the negative in this calculation because it's possible it might mess you up. All right, so pause the video at this point. Again, I've got a couple for you guys to practice. So 13 and 14 has you going through a couple of these, trying them out. Some are positive, some are negative. So again, don't let that negative throw you. Just kind of use it, throw it off to the side until the end. And then when you're done, come on back and we'll talk about some number line stuff. All right, is everybody doing okay? Everybody was able to convert from mixed to improper and improper to mix, hopefully. So, and if you didn't, hopefully you messaged me so that way we can work out any kinks you might be having. So in this section, this is probably one of the trickier sections that we're going to talk about because all we're trying to do is graph a point on a number line. But instead of having a totally blank number line like we had in that first section and we had to decide what the tick marks looked like, they've already assigned certain tick marks to us, and we have to figure out with this current tick mark system, how do we actually put the tick marks in there in such a way to guarantee we can graph the number that we're trying to graph. So that's where this can get a little complicated, and this is where it kind of mess students up. So first thing, obviously, this isn't to scale because I just kind of have everything running straight down the middle, which is totally fine. But what we're going to do is, and this is the big part here, is we want to make sure we think about the denominator and stuff like that because that's going to help us determine how many tick marks we actually need. So with my example that I've got here, I'm trying to plot the point 5 over 7. And so they've given me 2 anchors in this case, 0 and 6 over 7. So not necessarily ideal, like I'd much rather have had 0 and 1, because with 0 and 1, I'd know exactly how to kind of divide this guy up. But with 0 and 6 over 7, I'm kind of like, all right, what do I actually do in this case? So the goal is, obviously we want our increments in terms of tick marks of 7, 1 over 7th units in this case. So one thing you could do is you could kind of estimate off to the side and try to take this up to make it into like where you think 1 would actually look like. Not that you have to, you don't have to do that, but you could just think about that just so then you would know it's like, okay, well, between 0 and 1, I know I need to have 6 tick marks, and I've already got 1 here. So if you didn't want to put the 1 down, you just need to use the top number to tell you how many more tick marks you need between the 0 and the 6/7. So the idea is I need to have a spot for 1/7, 2/7, 3/7, 4/7, and 5/7. So I've got to somehow get those in between my 0 and 6/7. So in this case, I need 1, 2, 3, 4, 5. I need 5 tick marks between 0 and 6/7 is the way you want to think about this problem. And again, you want them to be as equal as possible. So let me see if I can do a better job of like laying this one out, because I didn't do such a good job the last time. So let's put that 1 there, 2 there, and then 2 there. And if you wanted, if you wanted to be really particular, you could get a ruler and try to like divide it up that way. But I'm not, I don't expect you to be 100% accurate, but hopefully it's somewhat close. So in this case, let's label them just to verify that I didn't mess up my tick marks or something like that, and I don't end up landing at 6/7 like I'm supposed to. So 1/7, 2/7, 3/7, 4/7, 5/7. So good. So that's perfect. So I was able to divide between 0 and 6/7 up into 5 nice interval increments and stuff like that. So now that I've finally got that done, now I can go in and graph where 5/7 would be. And so again, I'm just going to shade or color in the dot right at 5/7. So again, be careful on this one because this can be a little tricky. So, and I've got a variety of things. Like the first one, you've got 0 and 1, then 0 and 3/2, 0 and 3/4, 0 and 4/5. So there's all kinds of different numbers, like -1, -2. So be really, really careful when you're dividing this up. Figure out what the bottom number needs to be so you know how many tick marks you are. Use that top mark, top number to help you figure out, all right, how many tick marks between here and there. So again, if you're having trouble, it might be on this problem. So if you do, just let me know so we can talk about it, make sure we end up on the right track. So again, at this point, pause the video. And then when you're done, come on back and we'll finish up this section. So, all right. So the last thing that we want to do in this section is be able to look at a number and try to estimate like where that number would land in relationship to 0, 1/2, or 1. Because those are sort of the big 3 anchor points that we're going to have for fractions. I mean, there's obviously tons and tons and tons of fractions, but those are a nice breakdown of the number line because it kind of divides the number like between 0 and 1 directly in half, and it gives you an idea of kind of how to categorize these guys. So how can I tell if a fraction is close to 1 to start off with? Well, the way we judge whether it's close to something or not is we sort of divide the 0 to 1/2 and the 1/2 to 1, each of those sections into halves again. So in this case, what we're looking for is we're looking for an x value that's pretty much greater than 3/4. So if our x is bigger than 3/4, then we would say that's closer to 1 in this case. And so another way that we can look at it is, there won't be that much difference between our top and our bottom number. So for example, 7/8, 5/6, 3/4, things like that. So the top and bottom number are relatively close together. So our top and bottom number are going to be pretty close together. So again, like 11/12, 10/12, things like that. So where there's not that much difference between the top and the bottom. All right, now for 1/2, so 1/2 has a pretty big range because we want to, because it can be less than 3/4, but then on the other hand, it can be greater than 1/4. So from like an inequality perspective, we're looking at x values that are bigger than 1/4, but smaller than 3/4 in this case. So it's kind of between 1/4 and 3/4. And so again, by looking at the numbers, what we're looking at is that the top number is about half or near half of the bottom number. So the top number so I'm going to use close to. So close to half the bottom number. So it could be close to above or it could be close to below. So for example, like 3 over 8 is pretty close to a half because 4 over 8 would technically be exactly a half. So that would fall in that near 1/2 range. Same thing, 5 over 8 would be a little bit bigger. It's bigger than 1/2, but again, it's still closer to 1/2. So if I had those two numbers, I would say they were closer to 1/2 in this case. And the top one, I don't think I wrote this down, but like 7 over 8 would technically be closer to 1 in this case. All right, and so 0 is just kind of like 3/4, but the opposite, or 1, but the opposite. So in this case, we're looking for numbers that are smaller than 1/2. And so what we're looking for here is that the pretty much the top number is getting really close to 1. The top number is really small. So the top number close to 1. So that's what we're looking at when we're trying to decide whether a fraction is closer to 1/2, 1, or 0 in this case. And so if you wanted to see what it would look like on a number line, like you could just jot this completely down. So again, I should have just drew 1/2 in there like already, but there's my 1/2. So in this case, I'm going to divide each of these sections up into halves. Whoops, this should be 3 over 4, sorry. So if we're in this range, we're going to be closer to 0. If we're in this range, we're going to be closer to 1. And then if we're in this humongous range, we're going to be closer to 1/2 in this case. All right. So I've got a bunch for you guys to actually practice on here. So again, practice 16 is going to be, using the denominator 9, try to write 2 fractions in each box that are close to 0, close to 1/2, closer to 1. And then 17, it's just giving you either the bottom or the top number. And in the first one, you're trying to make the fraction as close to 1/2 as you can, but smaller than 1/2. So you don't want it to be exactly 1/2, and you don't want it to be bigger than 1/2. So like, for example, the first one was 100. So if I put 50 in there, that would be exactly 1/2. So that one's no good. So that means I just need to go a little bit smaller. So I could use 49. And so you want to be like the closest you can get. I mean, clearly, like I could put 48, but that's not the best number that can go there. So try to put the absolute biggest number that can go there. So I don't want you to put 48 down, even though it is, less than 1/2. It's not the best number that's less than 1/2. So keep that in mind. We're looking for the best number that's less than 1/2. And then same thing for 18. So we're trying to get as close to 1 as we can get, but again, we want it to be less than 1. So again, like for 27, I don't want to put 25 because yes, it is less than 1, but there's a better number that I can use in that case. I can use 26. So I want to use the best number, the biggest number that I can get that gets me to that answer. All right. And then finally, the last problem, I think it's the last one. Yeah. It's a ton of practice problems. So when we share our answers, everybody should be able to take one practice problem in this case, since there's 19 different practice problems. So in this case, I've just got a ton of different fractions here, and you're going to list them in the boxes, which ones are closer to 0, which ones are closer to 1/2, which ones are closer to 1. So do your best, see how you can do on them. I'll be around all day tomorrow if you have any questions or anything like that. So good luck and have fun.